Hi, today we are going to discuss about an architectural design, the uses of Global ZEN IPs. There was a requirement from customer that they have a site where their bandwidth is around 5 Gbps of internet bandwidth. From all other locations, the traffic will be backhauled towards this particular central location using MPLS. This particular location having internet from a single provider and a dedicated CP was allocated for this customer. Customer wants Zscaler internet access service for this particular site. So from this site, the traffic will be routed to Zscaler. It may be through the GRE or IPSec. Customer was ready to do any kind of configuration. Since the bandwidth is higher than the normal, the GRE normally support 1 Gbps of bandwidth, whereas our bandwidth is around 5 Gbps as a requirement. So we propose two solutions to the customer. One is use the private service edges since the bandwidth is higher than 1 Gbps from the site. And the second option was use public service edges and enable GRE from the multiple public IPs from that site. Customer was agreed to go with option 2, but customer will not manage the policy based routing and huge routes on the CPE router. So he was not ready to do the configuration around policy based routing to send a specific traffic to a specific site or through the specific public IP. So it was very challenging one. So we said okay to use the option 2 with global ZEN IPs, and only the global ZEN IPs will be routed towards the tunnel. So the customer needs to apply only few routes in the CP route. So that was our plan, and we proposed the same to the customer. So just look at the solution implementation steps which we done for this customer. We created 5 loopback interfaces on the CP with public IPs. We take global ZEN IPs or PSE IPs, VIP IPs from ips.zscloud.net/CENR. We started routing the global ZEN IPs into the GRE tunnel. When you take first public IP, we will create a route for the first global ZEN IP, and next go hop of that particular route will be the inside internal IP of the Zscaler. In tunnel from tunnel public IP2, we will create a route for the second global ZEN IP. Likewise, we have created the routes for the global ZEN IPs to the GRE. We proposed use pack files for from the sites, and we verified the reachability of pack.zscloud.net, and somehow we established the policies through direct internet and identified the reachability. So if you would like to send this pack.zscloud.net to the GRE, you can very well use it. But again, the challenging part will be, so when you route this traffic, which through which tunnel the traffic has to be routed. So what we can do, we can create a specific subnets. If the traffic is coming from this subnet, the specific the pack.zscloud.net should resolve from any one of the specific tunnels. But the challenging part is customer was not agreed to create a PBR. So we we identifying the alternate options through the pack files. My IP address is equal to my IP address of will resolve the IP address of the users. So we have the customer had different subnets. So we propose the customer to send the traffic from specific subnet to the global ZEN IP1 and the standby to global ZEN IP2. The another subnet. So let's say we segregate the subnets into 5 different subnets. So um, each public each tunnel will carry one subnet of traffic in order to load balance the traffic. So we need to sit with customer and understand which subnet will take which traffic, how much traffic, bandwidth is needed. So those kind of informations we need to collect, and accordingly we have to create the pack files. Here in an example, I was given only 5 subnets, but the actual deployment may not be the 5 subnets. Okay, the first subnet will be routed towards the primary ZEN. If the primary downs, the traffic will be go to the secondary ZEN. So the primary ZEN IP is routed to tunnel 1 and from the public IP 1, and the secondary IP is routed towards the public tunnel uh, from the public IP 2. So likewise, we have the route pack configurations given to the customer, and um, the testing will be like the traffic from first subnet will go to the tunnel of public IP1 and the fallback to the public IP2. The traffic from the second subnet will go to the tunnel public IP2 and the fallback will be the public IP3. The traffic from the subnet 3 will go to the tunnel public IP3 and its fallback is public IP4. The traffic from the subnet 4 will go to the public IP4 and the fallback will be public IP5. The traffic from fifth subnet will go to the public IP5 and the fallback is the public IP1. Likewise, the traffic were routed towards the tunnels. So in this kind of scenarios where you have more bandwidth than the 1 Gbps, then the recommended option is private service edges from the site. And when you are using private service edges, you can use this particular traffic for multiple purpose like location awareness and geo compliance related stuff also you can achieve from the public service edges. You can send 80, not only 80 and 443, you can send all traffic from the tunnel and you can manage it through the GRE. And if the customer is able to handle it, the PBR in the routers where the GRE is terminated, then we can send all traffics from the sites. And we need to ensure that pack is resolvable from the network uh, so that we can use the pack files on user machines. And also the source IP subnets needs to be segregated based on the bandwidth. So we identified 5 public IPs to manage 5 Gbps of bandwidth, and assumption is one GRE site will handle 1 Gbps of traffic. So when you send the routes to the specific GRE tunnels, we need to identify uh, whether the subnet is handling can handle is the subnet is having bandwidth of 1 Gbps or more than that. If the bandwidth is more than 1 Gbps, then we have to divide the subnets again and split into 2 tunnels. Thank you for watching. Have a good day.